Hello guys! Welcome sa ating z-knowledgeTV.
Okay, so our next topic is about resistors. So our objectives for this topic, after successful completion of this unit, you should be able to define the basic concept of resistors and its resistance, use quantitatively the proportionality between resistance, the length, and the cross-sectional area of a wire. So identify various conductors used in electrical applications based on their resistivity. Analyze the effect of variations of temperature on the resistance of a material and other specification. And determine the value of a resistor based on the color coding.
So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started.
Okay. So, kapag nakita natin itong figure na to, so alam natin na ang tawag dito is a faucet. Tama? So, in this faucet, so, kinokontrol siya ng part na to. Tama? So, kapag yan ni-release, so, magkakaroon ng flow ng water dito. Tama? So, kapag naman yan nilak ulit, so, mawalan tayo ng flow ng water. So, this control ng faucet is maihahalin tulad natin siya sa resistor. Okay? So, ang resistor is siya yung nag-o-oppose ng flow ng current. Okay? So, kapag mataas yung value ng resistor natin, halos mababa na lang yung current natin. Kapag masyadong mababa naman yung value ng resistor, so masyadong mataas yung mag-flow ng current. Okay? So halos kasing siya dito sa gripo. Okay? So, resistor. So, a resistor is an electrical component that restricts. Okay? So, restrict. Sabi pa ng restrict is oppose. So, siya yung pumipigil. Okay, the flow of electrical current in a circuit. Okay, so meron tayong different types ng resistors. Okay, so lahat ng types niyan is may kanya-kanyang functions. Okay? Pero isa lang yung pinaka-goal nila, ang mag-restrict or mag-oppose ng flow of current. So, basic construction ng resistor. So, the resistance R of a component is dependent on its physical characteristics and can be calculated using this formula. Wherein yung P na yan o yung ρ is tinatawag natin na electrical resistivity of the material. So, yung L is the length ng material. Yung A is the cross-sectional area ng material. Okay? So, sabihin, lahat daw ng resistance natin, I mean, lahat ng makuha natin na value ng resistance is connected sa tatlong yan. Okay? So, ibig sabihin, ano man yung changes na meron sa kanila, magkakaroon tayo ng changes dito sa resistance natin. Okay? So, ito yung basic construction ng resistor. So, meron tayong length, meron tayong resistivity, meron tayong area. So, lahat yan kapag pinag-combine natin, makakuha tayo ng resistance, R. Okay? So, yung unit nila is yung tatawag natin na ohm. So, an ohm is the amount of resistance which passes 1 ampere of current when a 1 volt potential is placed across it. So, ito yung unit natin. Okay? So, ito yung factors affecting the resistance. So, sabi ko kanina, yung tatlong nasa formula natin is siyang makaka-apekto rin sa resistance. So, ano man yung mag-change sa tatlong yon, mag-change din yung resistance natin. So, unahin natin ang length. So, the resistance of a conductor is directly proportional to its length. Okay? So, kaya kung matatandaan nyo, ang formula ng resistance ay rho L over A. Okay? So, since na yung L is nasa numerator, so, isipin nyo na itong part ito is just a constant. Okay? So, therefore, kung constant yan, so, magbago man yung L, kuwari, nag-increase yung length. So, mag-i-increase din yung resistance natin. Kapag nag-decrease yung length, so mag-decrease din yung resistance natin. Okay? So, sa cross-sectional area naman. So, the resistance of conductor is inversely proportional. So, tandaan nyo naman, inversely proportional. So, meaning, kapag yung babalik natin itong formula natin na R is equal to resistivity over area, so, pansin nyo na yung area is nasa denominator. So, meaning, kung ito naman ang gagawin yung constant, so, ang magiging itsura niya is R is equal to just a 1 over A. Tama? So, meaning, kapag lumaki yung current mo, ay yung area mo, okay, so, bababa yung resistance mo. Pero, kapag bumaba ang cross-sectional area mo, so, tataas naman yung resistance mo. Okay? Kasi inversely proportional sila. Okay, so meron tayo yung comparison between circular and square mills. So, ano ba yung circular square mills na yan? So, unahin natin ng square mill. Square mill, it relates to a square conductor. So, pa-square daw yung conductor niya. So, imbis na circle, so square. So, possible na maging ganyan ang itsura niya. Okay? So, ito yung kinukuha natin. Yung cross-sectional area. Yan. Okay? So, is the cross-sectional area of the square conductor that has a side of 1 mil. So, next, yung circular mill naman is the cross-sectional area of a circular conductor having a diameter of 1 mil. So, kung dito, meron tayong side na 1 mil. Okay? Sa circular naman, so, since na circular, circle yan. So, pa-circular din yan. Okay? So, circle yan. Ito yung kinukuha natin, yung cross-sectional area. So, ang diameter daw niyan ay 1 mil. Okay? So, again, so ito yung example natin. So, square mill at circular mill. Okay? So, ngayon, pwede natin ma-relate daw yung 1 mil ng square at 1 mil ng circle. So, these are the relationship. So, meron muna tayong circular mill na equal siya sa d squared. Okay? So, yung d is yung tatawag natin diameter ng conductor in mils. So, take note na yung 1,000 mil ay 1 inch ang equivalent niya. At yung 1 mega cm o circular mil is meron tayong 1,000 circular mil. Okay? So, this is na the relationship ng circular mills at square mills. So, meron tayong 1 circular mill na equivalent siya sa pi over 4 square mill. Okay. So, next. So, ano pa ibang factor na nag-affect ng resistance? So, resistivity of the material. So, depending upon on their atomic structure, different materials will have different quantities of free electrons. Therefore, the various conductors used in electrical applications have different values of resistance as shown in this table. Okay? So, ibig sabihin, anumang material na ginamit sa kanya, so merong equivalent na resistivity yon. Example, kung ang ginamit na material sa kanya is silver, so merong resistivity na 1.64 times 10 raised to negative 8. So, kung germanium ang ginamit sa kanya, so merong 47 times 10 raised to negative 2. So, kung glass, 10 raised to 12. Okay? So, pansin nyo, na yung may pinakamaliit na resistivity, so conductor yon. Okay? So, ibig sabihin, malaki yung possible na daluyan siya ng kuryente. Unlike kapag masyado mataas yung resistivity, okay, ito, naka 10 raised to 10, 11, 12, 12. So, ang tawag sa kanila, insulator. So, dahil sa sobrang laki ng resistivity nila, so, mahirap na silang daluyan ng kuryente. Kaya sila insulated o insulator. Okay? Then, yung nasa middle nila, okay? So, semiconductor yon kasi may part pa rin sila na pwede silang daluyan ng kuryente. Okay? So, next, temperature. So, the effect of variations of temperature on the resistance of all materials is generally are as follows. So, resistance of most of the metallic conductors usually increases with rise in temperature. So, resistance of non-conductors or insulator usually decreases with rise in temperature. So, malaki talaga yung effect ng temperature pagdating sa resistance natin. Kasi, kapag sobrang init, so nag-expand yung material natin. So, kapag nag-expand yung material, lumaki yung length. So, therefore, lalaki din yung resistance natin. Tama? So, dito, sa temperature, meron tayong formula. So, R1 over R2 is equal to T plus T1 over T plus T2. So, another set of formula is R2 is equal to R1 multiplied by 1 plus alpha 1 times T2 minus T1. So, meron din tayong alpha na 1 over T plus T1. At meron tayong T na 1 over A0. Ngayon, ano ba yung mga variables na yan? So, yung R1 is yung tatawag nating resistance at temperature T1. So, siya yung siya yung first resistance natin at initial temperature. So, yung R2, siya yung final resistance natin o second resistance in second temperature or final temperature natin. Okay, yung T1, initial temperature in degree Celsius. Yung T2, final temperature in degree Celsius. Then, yung malaking T is siya yung inferred zero resistance. So, siya yung temperature when resistance of a certain material is zero. Okay? Kapag yung temperature natin is nasa zero, siya yung big T. Okay, yung capital T. Then yung alpha, siya yung temperature coefficient of a resistance. So, ang unit niya is per degree Celsius. Or pwede rin natin sabihin na degree Celsius raised to negative 1. Okay? So, yung A0, siya yung temperature coefficient of resistance at 0 degree Celsius. Okay? Note. If for an increase in temperature, the resistance of material increases. So, sabi natin kanina, sa formula ng resistance is equal to rho L over A, wherein yung L is direct proportional sa resistance. It is said to have a positive temperature coefficient. So, a material whose resistance decreases with an increase in temperature has negative temperature coefficient. Okay? So, a temperature coefficient is a parameter refers to that constant in which the resistance changes per degree Celsius. So, unit niya is C degree Celsius raised to negative 1. So, for the resistor specifications, okay? So, unahin natin ang nominal resistance. So, the nominal resistance is the resistance that can be expected when ordering a resistor. So, siya yung kapag bibili tayo ng resistor sa hardware, okay? So, ang una natin titignan is yung nominal resistance kasi siya yung mismong value. Okay? So, next, the tolerances. So, a manufactured resistor has a certain tolerance to which the resistance may differ from the nominal value. So, ito yung kaya nagbibigay si manufacturing ng resistance value na may tolerance is para sakop na yung pinaka-specs natin. o yung pinaka-nominal resistance natin. So, ibig sabihin, kapag nakita tayo ng plus minus, kuwari is 10%, okay? Sabihin, tolerance yan. So, example, meron tayong nominal na 100 ohm na may tolerance daw na plus minus 10%. So, ibig sabihin, kunin natin yung 10% ng 100. Okay? So, next, power rating. So, because the purpose of a resistor is to dissipate power in the form of heat, the resistor has a rating in watts in which the resistor can continue to dissipate before the temperature overwhelms the resistor and causes it to overheat. When a resistor overheats, the material begins to melt away, which will cause the resistance to increase usually until the resistor breaks. So, ito yung tinatawag natin na nagsasabi kung hanggang saan lang kaya nung resistance natin, yung resistor natin. Okay? Kasi alam natin na yung resistor is nagde-dissipate ng heat. So, kapag na-reach na yung ganitong amount ng power o ng heat, so possible na mag-break na yon o possible na pumutok na siya. Okay, kaya naman sa specs natin, nakalagay rin yan. Kasi para malaman ni customer na hanggang dun lang yung kaya nung resistor na binili niya. Next, operating temperature. So, related to power rating, the operating temperature is the temperature that the resistor can continue to operate before being destroyed. Okay, so, siya yung operating temperature lang na kung saan, ito lang yung pwede. Okay? Dapat na dito lang siya gamitin sa temperature na to. Okay? So, maximum voltage. So, in order to avoid spark overs or material breakdown, a certain maximum voltage over a resistor must not be exceeded. So, the maximum voltage is part of a resistor's specification and typically a function of the resistor's physical length, distance of the leads, material, and coating. Okay? So, ito naman yung maximum na voltahe lang na kayang support ng resistor natin. So, kapag na-reach na yung maximum voltage or nag-exceed siya dyan sa maximum voltage na, so possible din na mag-breakdown yung resistor natin. So, temperature coefficient. So, this parameter refers to the constant in which the resistance changes per degree Celsius. So, next, for the resistor color coding. So, resistor values are often indicated with color codes. All leaded resistors with a power rating up to 1 watt are marked with color bands. So, ito yung makikita nyo sa pinaka-umpisa ng slides natin na resistor. So, ang tawag doon is leaded resistor na meron siyang mga band ng color code. Okay, so the coding is defined in the International Standard or IEC 60062. This standard describes the marking codes for resistors and capacitors. So in addition to defining the color bands, so the standard also includes numerical codes as often used for surface mount SMD resistors. So the color code is given by several bands. So together they specify the resistance value, the tolerance, and sometimes the reliability of failure rate. So ito yung makikita natin na equivalent daw ng bawat color codes. Okay? So the number of bands varies from 3 to 6. So minsan may makikita tayong tatlong color code lang, minsan 6. So lahat ng color code na yun is may equivalent. Okay? So at a minimum, 2 bands indicate the resistance value and 1 band serves as multiplier. So the resistance values are standardized. So these values are called preferred values. So take note that the resistors that are produced according to military specifications sometimes include an extra band to indicate reliability. So para naman to sa mga military specs. Okay, dahil alam natin na dapat ang military specs is halos perfect. Kasi once na hindi siya ganun maging ideal, possible na magkaroon tayo ng problem doon. Okay? So, the table shows how to determine the resistance and tolerance for resistors. It can also be used to specify the color of the bands when the values are known. So, ito yung table natin. Okay, so meron tayong hanggang 6 band. Okay, so dito, pansin natin na meron tayong significant figures, multiplier, tolerance, temperature coefficient, and the fail rate. Okay? Okay, so dito sa pinakamababang strip ng color code, which is the 3 band, so yung dalawang strip daw dyan is para kay significant figures. Then yung pangatlo is para kay multiplier. Wala tayong ano dyan, wala tayong tolerance. Okay? Pero, kapag nag-4 band na tayo, okay? So, yung pang-apat na band is para kay tolerance. Okay? So, pag kay 5 band, so, same pa rin yung dalawa natin. Kaya lang, manadagdagan pa tayo ng isa pang significant figures. So, magiging 3 na siya in total. So, then yung pang-apat na strip, siya yung multiplier natin. Then yung pang-5, so siya pa rin yung sa tolerance. Okay? So, sa 6 band, yung first 3 is para kay significant figures. Yung pang-4 sa multiplier natin. Yung pang-5 is sa tolerance. Yung pang-6 ay pinasok na yung temperature coefficient. Okay? So, take note na a gold band in magnitude position means -1 but means 5% tolerance lang. So, kapag gold ang nakita nyo sa dito sa 4 band, ang nakita nyo is gold. So, meron lang siyang 5% tolerance. Kapag naman nakita nyo is 10% tolerance, meron daw siyang magnitude position means -2. Okay, so 10% tolerance naman siya. Okay, so example. A platinum resistance thermometer uses the change in R to measure temperature. Suppose R0 is equal to 50 ohm at T sub 0 is equal to 20 degrees Celsius. What is R when T is equal to 50 degrees Celsius? So hint, alpha for platinum is 3.92 times 10 raised to -3 degrees Celsius raised to -1 in this temperature range. Okay? So, ang gagamitin natin na formula rito is ito. Bakit? Kasi meron tayong given na initial resistance or resistance at 0 degree. So, meron tayong initial temperature na 20 degrees Celsius at meron tayong inferred temperature, okay, na 50 degrees Celsius. So, meron tayong alpha ng platinum. Okay, so kapag dinirect substitute natin sa mga yan, so ganito yung makakamap natin. Okay, so therefore, magiging sagot natin is 55.88 ohm. Okay, so that will be the resistance using this formula natin para sa mga temperature. So next. So what is the resistance of a 100 meter length of round copper wire with a radius of 0.3 mm? So take note na yung copper resistivity natin ay merong 1.68 na 10 raised to -8. So using formula ng resistance and resistivity, so ito yun. So yung R is equal to rho L over A. So, since the copper wire is round, okay, thus its cross-sectional area will be in this one. So, using the formula ng area ng circle. So since ang radius na given natin is 0.3 millimeters, so, pwede natin siyang sabihin na 0.3 times 10⁻³ Okay? Or pwede natin siyang sabihin pa as in this term. So, by getting the square ng radius, so makakuha tayo ng area ng 2.83 times 10⁻⁷ square meter. Thus, Yung by substituting natin na all the given and the computed area, so makakompute natin itong resistance natin. So therefore, ang resistance natin is 5.9364 ohm. Okay? Next. So what is the color code of 333 kilo ohm with plus or minus 5% na tolerance, 5-band resistor. So, since sa 5-band resistor siya, so ito yung gagamitin nating color code table. Okay. So, sabi, meron tayong 333 kilo. Okay? So, pansin natin to, kunin natin itong 333. So, saan siya? So, 333. So, meron tayong tatlong 3. So, nasa orange siya, di ba? So, yung K natin is just 10 raised to cube. O, 10 raised to 3. Tama? So, ibig sabihin, dito pa rin siya papasok. So, therefore, ay ang magnitude natin na yan, na resistance, ay dito pupunta. So, sa orange, 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 orange. So, 4 na orange. So, itong 5% naman. So, saan natin siya makikita? Sa part ng tolerance. Kasi ito is, ang tawag dito ay tolerance, di ba? Okay. So, saan siya? So, ang mga tolerance natin, dito lang natin tignan. So, alin dito yung mayroong 5%? So, ang 5% dyan is ito. Okay? Nasa part siya ng gold. So, therefore, yung 5-band resistor natin ay may color code na orange, 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 and gold. Okay? So, that's the end of this presentation. So, thank you for watching. Thank you for listening. So, God bless.